All right, let's talk about math. We all spent years, and I mean years, sitting in math class. But what if I told you that most of what we learned, all those formulas, all those procedures, isn't really what mathematics is about at all? Today, we're going to pull back the curtain and find out what math truly is. I mean, does this feel familiar? For so many of us, this is exactly what math class was. Just a long, long list of rules to memorize and steps to follow. Solve for x, find the derivative, do it again. It felt a lot less like a creative subject and more like, I don't know, just following a recipe, right? But is that really the whole story? Not even close. You know, the mathematician Keith Devlin has this fantastic analogy. He says that focusing only on the rules in math is like teaching someone to play soccer by only making them do drills. Yeah, you can learn to pass and shoot perfectly, but you'll never, ever understand the strategy, the flow, or just the beauty of the actual game. School math, a lot of the time, just teaches us the drills. It completely misses the game itself. So if what we learned was just the drills, what's the real game? Well, let's get into it, because the math in your old textbook is just a tiny, and I mean ancient, slice of a much bigger, way more exciting world. Just look at this. The math you probably studied is, to be blunt, ancient history. Arithmetic, that got started 10,000 years ago, basically for trading and money. The geometry with all those proofs, that's from ancient Greece, more than 2,000 years old. Algebra popped up in the 8th century. And calculus, which feels like the peak of high school math, that was invented way back in the 1600s. But here's the real kicker. Most of the math that actually powers our world today, we're talking everything from your GPS and the internet to modern medicine, was developed in just the last 200 years. There has been this massive, unbelievable explosion of mathematical discovery that most of us never even get a hint of in school. So what is all this new math then? Well, this is where it all clicks into place. This is the big reveal that might just completely change how you think about this whole subject forever. You ready? The modern definition of mathematics is simply this: the science of patterns. That's it. A mathematician's job isn't just to crunch numbers. It's to be a pattern detective, to find them, to describe them, and to understand them, wherever they might be hiding. And patterns means so much more than just stripes or polka dots. Yeah, we're talking about patterns of numbers, of course, but also patterns of shape and patterns of motion, which is what calculus helps us see. Even patterns in how we reason, patterns of chance you'd see in a casino, and these really abstract patterns of how things are close to each other. They are literally everywhere. Okay, I can hear what you're thinking, but what about all those insane symbols and formulas? That's the part I really hate. And you're right, for a lot of people, that notation feels like this impossible wall. But what if we've been looking at it all wrong? This quote just nails it. Those symbols on the page, that's not the math, any more than the notes written on a piece of paper are the music. It's just the language we invented to write it all down. Think about it like this. Sheet music is just a bunch of dots and lines on paper. The real music is the symphony that comes alive in your head when you hear it played. Well, it's the exact same for math. The symbols and formulas are just the sheet music. The real mathematics is this abstract symphony of ideas that comes alive in your mind when you understand what it all means. And this language, this sheet music for ideas, is unbelievably powerful. It's like putting on a pair of X-ray glasses that suddenly let you see all the hidden structures and invisible forces that make the world work. This is my absolute favorite way to put it. Think about it. You can't actually see the aerodynamic forces that are holding a 400-ton airplane up in the sky, can you? Of course not, they're invisible. But with the language of math, we can see them, we can describe them, we can predict them, and we can harness them to do incredible things. Now, this powerful new way of thinking didn't just appear overnight. It was actually part of this quiet revolution that happened back in the 1800s, and it fundamentally changed the entire goal of math, from just doing stuff to truly understanding stuff. So here's the big shift. For hundreds of years, being good at math just meant you were a fast and accurate human calculator. But around the mid-1800s, the whole game changed. Mathematicians realized it was way more important to understand the deep, underlying concepts. The focus moved from how do I calculate this to why does this work? And let me tell you, this new way of thinking led to some truly wild, brain-bending results. Get this. There's something called the Banach-Tarski paradox, and it proves with flawless logic that you can take a solid ball, cut it into a few special pieces, and then put those pieces back together to create two solid balls, each one identical to the original.
It's impossible to visualize, but mathematically, it's true.
Okay, so weird paradoxes about magic spheres are cool, but why does any of this abstract thinking actually matter in the real world? Well, it turns out this new kind of mathematical thinking is actually one of the most valuable skills, a secret superpower you can possibly have today. Let me ask you a quick question. In the entire United States, with all the giant tech companies, Wall Street banks, and huge universities, which single organization do you think hires the most people with PhDs in math? The answer, and it's not even close, is the National Security Agency, the NSA. And their main job isn't doing calculations, it's pattern analysis on a mind-boggling scale. They use this super high-level math to find patterns in data, to break complex codes. That's modern math in the real world. And this really gets to the heart of it. We all carry a supercomputer in our pocket that can calculate way better than any human. The world doesn't need more human calculators. What it's desperate for are innovative thinkers. You can really break it down into two types of thinkers. First, you have the problem solver. You can give them a problem that's already set up with math and they can solve it. That's thinking inside the box. But the second and far more valuable person is the innovative thinker. They can look at a messy, new, real-world problem and figure out how to even describe it using math in the first place. That's thinking outside the box. You know that old saying, right? Give a person a fish, you feed them for a day. Teach them how to fish, you feed them for a lifetime. It is perfect for this. Teaching someone one formula is like giving them a fish. It works for one problem. But teaching them how to think mathematically, that's like teaching them how to fish. It's a skill they can use forever on any problem that comes their way. And this isn't just some nice idea. You can see it happening. The demand for people who are basically just human calculators is flat. It's not going anywhere. But the demand for creative, mathematical thinkers who can solve new problems, it is absolutely skyrocketing. So math isn't just a subject you have to get through in school. It's a whole new way of seeing the world. It's a tool for finding the hidden patterns that shape absolutely everything around us. So the real question to leave you with is, now that you know this, what invisible patterns will you make visible?